creo que estabas diciendo algo, perdón. A la grabación. We're
Eh,
recording.
¿Les parece si ya damos inicio?
Sí, sí, sí.
Ok. Buenos días con todos. Gracias por estar aquí. El capítulo estudiantil IEEE de la Escuela Politécnica Nacional, CONSOC, les da la más cordial bienvenida al taller ThinSpeak, dictado por profesionales del Centro de Investigación de MathWorks. Este taller tiene una duración aproximada de 2 horas. Las preguntas se las realizará al final, puede ser en el transcurso. No sé si me confirman eso.
Sí, sí, pueden hacerlas en el transcurso en el chat.
Ok, entonces pueden hacer su pregunta a través del chat. A continuación, voy a dar paso a los expositores. Bienvenidos, gracias por estar aquí.
Muchas gracias, Nubia. Y gracias a ustedes por estar aquí. Bienvenidos. Para nosotros es un gusto estar aquí con la IEEE de EPN. Y bueno, mi nombre es Gaby Arellano. Yo trabajo en el área de, básicamente como ingenieros de aplicaciones en el área de educación. Y yo trabajo con universidades de Latinoamérica, ayudándolos con el uso de nuestras herramientas para investigación, para la parte de aprendizaje y de enseñanza. Yo soy ingeniera mecánica y vivo ahorita en la zona en Dallas, Texas. Bueno, hoy quienes van a estar presentando son Christopher y Ram, así que les voy a ceder la palabra a Christopher and Ram, if you want to take it over. It's all yours.
Sure. Thanks, Gabby. So hello, everybody. Good morning. Welcome to today's session on the Internet of Things, ThinSpeak, and MATLAB. This is for the IEEE EPN. We'll just start off by letting CJ, would you like to introduce yourself?
Sure. Yeah, I guess I noticed that you guys referred to me as CJ, and we only put Christopher on the slide, so it's you can call me either Christopher or CJ if you'd like. Hi, I'm the product manager for ThinSpeak at MathWorks, and pretty happy to be here. Excited to tell you more about ThinSpeak, and hopefully hear if you've done anything, hear about what you've done. So, thanks for the
Excellent.
invitation.
Thank you, CJ. So without further ado, let's get started. So for the session today, we have a pretty straightforward plan. So our goal for the session is to show you how you can use ThinSpeak as well as MATLAB for your IoT projects. Speaking about IoT projects, we want to make sure that at the end of these 90 minutes or 2 hours, when we have done with the presentation, you can go back to working on your first, if not furthering your IoT project efforts. So with that said, the agenda for today is we'd start off with an overview of what is Internet of Things, IoT for short. We'll then talk about how you can accomplish IoT projects using ThinSpeak and MATLAB. We'll then look at a few demos. So we don't want to keep this only in PowerPoint. So we want to make sure we show you a little bit of MATLAB, a lot of ThinSpeak, and we have a real world demo for air quality monitoring. And then once we're done with this, we want to share with you more project ideas as well as resources, freely available resources that's available to everybody, not just at EPN, but everybody on the call as well. With that said, please let us know through the chat if you have any questions at all. If you're going too fast, if you're not clear about what you're saying, do think about the projects or your courses that you're working on, and let us know if you have any questions as you go through in the chat. And again, please feel free to use English, Spanish, whatever medium you prefer, and we will definitely answer your questions. With that said, let's just test if the chat is working. To do so, I have a quick question for everybody. Has anybody used ThinSpeak for their IoT applications or projects? If yes, please say so in the chat. If no, please say so in the chat as well.
Got 2 solid votes so far. Fantastic.
Okay, I see a good number of you are telling us that you have not used it, so that's good to know. Probably another follow-up, this is going to be my last question before we start our presentation, is has any of you, have any of you used MATLAB for projects, for curriculum, for research, whatever be the reason? Have any of you used MATLAB?
And please continue to answer the ThinSpeak question. That'll help us design the rest of the flow of the talk as well. I think we could probably say that Gabby and I have also used MATLAB, just to let you know, Ram.
Yes, thank you, CJ and Gabby. Okay, excellent. Okay, so it looks like I do see a few of you have used MATLAB, but have not used ThinSpeak. So again, don't worry. The reason we're asking this is we want to make sure that what we are showing you today is appropriate for your level, and we want to make sure you get something out of it. Um, okay, excellent. Thank you so much for your responses. So with that said, we'll kick things off and we'll get started with a little introduction into Internet of Things, or IoT in short. So Internet of Things really, as the word suggests, is an interconnected, it's about things which can be people, devices that are connected by the internet. And now this is a big topic that has been in vogue for the last decade or so, with a lot of excitement about how things can be remotely controlled. So for example, me sitting here in Boston or Gabby sitting there in Dallas, we can remotely control our devices, which are probably in Quito, Ecuador. And that's the power of Internet of Things that lets you accomplish. So at a very high level, to think about what is IoT, you could look at this diagram and get a sense of what it does. So first, we have, as you can see, these smart connected devices, which are technically your embedded devices, which are connected to sensors that measure something that measures a certain quantity. So for example, it could be an embedded device that has sensors to measure your temperature, pressure, humidity, such physical parameters could be an example. Now, these devices, when they measure the data, they transmit it to the cloud. So that brings us to our second part, which is the cloud, where all of this data is being stored and can be shared. Now, this data, this is kind of where ThinSpeak falls under, however, is all of this is stored on the cloud. And the benefit of storing on the cloud is that it can be accessed later on, or anybody with the right privileges can access it for their purposes as well. With that said, the third part of it is when think of it as you as a user who has access to a desktop, maybe developing an algorithm, maybe prototyping an algorithm or modeling your data that was actually stored on this cloud. So you access this data on the cloud to perform analytics and develop algorithms. Now, these algorithms can then be shared either back to the cloud, or they can be pushed over or deployed into these smart connected devices. So at a high level, there are three important things. One is your devices on the ground, the cloud, where your data is aggregated and stored. And the third part is the engine or your desktop engine, where you're actually performing algorithmic development as well as analytics. So with that said, let's look at where is this Internet of Things applied. Like, I'm sure you've heard of Internet of Things, and it's it's a pretty fancy term right now, but where is this applied? So one of the first applications that come to my mind is in smart home applications. A lot of you may be familiar with Google Home, Alexa, your Ring doorbells that let you in and out remotely, and so on. So a lot of applications, like for example, if I'm in again Quito, Ecuador, and I want to open my home door to let a parcel in, I can do so using applications like Ring, Wise, and so on and so forth. And that is, again, applications of internet and smart devices that fall under smart home. Another application is in agriculture. Internet of Things is revolutionizing agriculture just by the ability to remotely monitor plants, remotely understand the coverage areas, soil moisture information, so on and so forth. And it's doing so by digitizing, as a part of it, by digitizing and providing and gaining access through the internet. The other industry, which I'm sure a lot of you are already familiar with, is the healthcare and the wearables industry. Well, again, a lot of us may have our Fitbits, Apple watches, so on and so forth. And again, the beauty of it, is it is collecting all your vitals information, and again, all of it is stored on the cloud. Again, you can perform analytics to know whether you're healthy, what are your goals, how can you improve your goals health-wise, so on and so forth. Another concept that you may have heard of is the industrial Internet of Things. Again, it's the same idea applied on a large scale to industries. And the benefit here is the automation part of it, where you're trying to remove human intervention and apply it to large scale processes in an industry. Finally, if you apply this and the concept of Internet of Things, the concept of interconnectivity to an entire city, especially now given the pandemic, the concepts of smart city, the concepts of actually passing on information as quickly as possible becomes essential, and that's another application of Internet of Things. So with those applications, a question you may have is, well, if I'm interested in Internet of Things, what are the industries that it affects? The good news is it almost affects every industry. When I say affects, it's been revolutionizing these industries and in a very positive manner. So all the way from your aeroplanes to defense, to automotive industry, we're talking about self-driving cars. Biotech, we saw the wearable space, medical devices, communications, electronics, to large-scale transportation systems like railway systems, as well as into manufacturing through the industrial Internet of Things. Almost every industry is being revolutionized by the various possibilities that Internet of Things offers. So while we know that it is having a positive influence on a variety of industries, a natural question you may have is why Internet of Things? And there are two simple answers to it. One is it lets you do things better and more smarter. Like you may already see, one of the things we saw is words like smart agriculture, smart homes, smart cities. The idea is you're not just increasing the efficiency of your output, you're also reducing human intervention. What that means is you're letting things happen more automatically. For example, let's think about the example where I have I have a simple a temperature controller, a temperature sensor here in Boston, but I'm visiting Quito, Ecuador, to meet all of you. However, I want to make sure that I want to keep monitoring my temperature. And if the temperature is too low, I want to open a certain heat vent. Now, I don't want to travel back and forth between Boston and Quito to be doing this. However, the power of Internet of Things lets me remotely switch on or switch off the heat vent depending on the temperature at that point. Again, you see, this is a way of automation, and it shows you how you can effectively work with remote operations. And that brings me to my second point, is Internet of Things lets you solve many problems that earlier were considered extremely hard to solve or almost impossible to solve. So it's not just about the quality of life improvements like your smartwatches and your smartphone devices, but it's also the ability to work on remote sensors and operate on remote devices sitting in the comfort of our homes. So that is probably the motivation behind Internet of Things, which is to do things smarter as well as to do new things to solve new problems. So that said, now that let's say we understand the Internet of Things, let's talk about how we implement a solution, how we'd go about starting or working on a project with the Internet of Things. Now, the Internet of Things workflow is fairly straightforward. in the sense that it's divided into three parts. The first one could be to collect your data. So remember, we were talking about multiple sensors like your humidity sensors, temperature, pressure, so on and so forth. These, when they're hooked up to a certain embedded device, your first step could be to collect this sensor data and then share it privately to the cloud. The next step on the cloud would be to analyze this data and try to identify insights from your data. Now, data is just raw data, it's just numbers. It could be a text, etc., but it's just at the end of the day, just numbers. And you want to translate these numbers, you want to transform these numbers into something more valuable, which is information. And that's really the fundamental step two, which is analyze and visualize your data. The third step, finally, is to act on your data. Now, this is extremely crucial in the Internet of Things, is once you have determined certain insights, you want to act on those insights. And when I say act, as going back to my example, in that case, it was I had a temperature sensor. Now that's correct. Once I've analyzed, which is identifying if it's too cold or too hot, the act part is switching on or turning on or opening a heat vent. Now, that is the kind of action you could take. Now, again, there are different kinds of actions you could take as well. And that's just to summarize what we're doing is collect using a sensor, analyze, again, you'll see some nice plots, visualizations, trying to understand trends in your data. And the final step, as you were saying, is you could either change the state of a system or you could tweet a message with an update. You could send an email, or again, change the state of a such system. So those are the three steps in an Internet of Things workflow. However, a lot of you mentioned that you're new to Internet of Things. So when you look at these three steps, you may have many questions, such as, what do you mean by cloud? Where is the data going? Do I need a dedicated web server to accomplish this? Do I need web development experience? You're talking a lot about the cloud. Do I need to be an expert programmer? Do I need to have web development experience to be able to complete a very basic project that I just outlined? How do I analyze the data? Like what kind of computational software I have to analyze data on the cloud? How do I get access to it on the cloud? Or how do I set up reactions? You said reactions are extremely important. Acting on data is important. How do I set it up? So don't worry, that is where ThinSpeak and MATLAB come in, and they make it extremely easy to work with your Internet of Things data on the cloud. And that's kind of what we're going to see through our demos as well as a presentation today. So let's talk about what is ThinSpeak. So ThinSpeak is a website for people. So as you're going to see today, we will simply be going to thingspeak.com, and you'll notice we can look at our own IoT data, or you can look at other publicly available IoT data from other users as well. So it lets you, just like any other website, it lets you interact and look at data and visualizations that can be created by you or by others as well. Secondly, it's a web service for devices. Remember, we said one of the steps is to send your data from the ground, from your sensors to the cloud. And that's kind of what ThinSpeak lets you do. So it lets you aggregate or collect data from your sensors. And the beauty of it is it also lets you almost instantly visualize and analyze your data on the cloud. So think of ThinSpeak as a data aggregation, an IoT platform on the cloud that is hosted by the MathWorks servers. So it's really an Internet of Things. It's really a Internet of Things a platform that lets you work with your data on the cloud. So that said, that brings us to our first demo, and that is to show you what the Internet of Things platform that we have called ThinSpeak is. And to do so, you can follow along with me, or if you've already done this, feel free to just watch me go through the different steps. So the first step, what we're going to do here is we're going to show you what's ThinSpeak website look like. And I'm going to pause here before I jump into my demo. I'm going to pause to see if you have any questions or any comments.
Thank you, Ram. Just gonna make a quick note in Spanish about like how important it is to know your experience or experience of people with ThinSpeak. So if you don't mind, I'll just make that.
Sure, please go ahead.
Sí, no, para aquellos que se acaban de unir, porque veo que hubo gente que se unió ahorita, si nos podrían por favor decir cuál es su experiencia con ThinSpeak, esto nos ayudaría mucho a decidir qué áreas del demo mostrar y dónde enfocarnos, ¿sí? Porque bueno, si ya lo han usado mucho y son expertos, pues a lo mejor podemos mostrar cosas más avanzadas, pero si nunca lo han utilizado, pues nos podemos enfocar más en las cosas básicas. Entonces nos pueden poner en el chat algo como que nunca lo he usado, un poquito, soy experto, lo que quieran. Okay. Gracias, Sebastián. Yeah, Sebastián said he doesn't have experience.
Okay. I was also, Gabby, just to confirm, I see a comment from Michael Prado. Was that something similar?
Yeah, he just translated what CJ wrote. So,
oh, okay, I see.
Yeah.
Perfect. Thank
Yeah.
you.
Thank you, Michael, for that. Okay, so we have all replies of people that don't have any experience.
Okay, excellent. So again, you're in the right place because we're going to start from scratch and we're going to learn how you can use ThinSpeak for your IoT project. So thank you for your, thank you, Gabby, and thank you for letting us know. And again, please use the chat to let us know if you have any questions. If any of this seems like a stretch or you're not able to understand, please let us know and we'd be happy to address them. Okay. Excellent. Okay, so we will move on with our demo. So the first demo is just to look at what ThinSpeak is. I'm sure you already looked at this image. And the way I got here is I went to thinspeak.com on my web browser. And the first thing that it's asking me is for my email. Now I'll highlight that ThinSpeak, you can, if you have a MathWorks account, that's a MathWorks account that you've created with any of your Gmail or your school.edu account, you can use that here to log in. If you don't have one, you can click on create one, and that'll let you create an account. And again, it's a fairly straightforward process. It just asks for your email address, your first name, last name, and that is it. It's a very straightforward process to create an account, and it's completely free. Before we jump into the account, I'd like to highlight a few things about the license that everybody has access to. Now, everybody has access to ThinSpeak, and it falls under the free license. You'll notice we will be talking about what each of these mean, but just remember that if you have an academic license, which is again a license created specifically for universities, faculty, researchers, students, then there are a few differences, such as you can work with larger projects using the academic license. You have more messages that are supported, a quicker update of each of your messages. So it's more instant, it's more closer to real time, more channels, and so on and so forth. But having said that, today we can just see how we're going to use the free version or the free license for ThinSpeak. So with that said, I'm going to log in with my MathWorks account. Again, this can be any account that's registered with the MathWorks. I mean, it's a MathWorks account. It doesn't need to be mathworks.com. It'll probably be Gmail, epn.edu, or so on for you. Let's see if I remember my password. I do. Excellent. And let us look at what ThinSpeak looks like. So here you go. This is what ThinSpeak looks like. And you notice there are quite a few examples depending on what you're trying to do. If you're interested in environmental monitoring, agriculture, energy monitoring, there are some examples you can look at. There are also other useful links that you can see here to get started. Many of them point to our documentation, which I know CJ is going to be showing you. But if you want to see what are projects like monitoring traffic, predicting tides, energy data analysis, all of this, if you want to get a sense of what you can do, there are a lot of links here that will help you get started. And there are also some tutorials, again, all of them available freely so that you can quickly get started on your IoT journey. With that said, we will start by looking at something called channels in ThinSpeak. Now, channels are how data, the IoT data, is stored in ThinSpeak. So to get started, I will show you what a channel looks like, and then I'll show you how to create a channel. So what I'm going to do here is I'm going to look at public channels. Now, these are channels that are created by other users, other ThinSpeak users. There are several thousands of them in the world, and they have made it public so I can look at them as well. Now, let me look at the very first channel, which looks to be somewhere in San Diego, Uruguay. And you'll notice this is what their channel looks like. This is what their IoT data dashboard looks like. You'll see we have in a certain location, which is San Diego, Uruguay. They're measuring the temperature, which is almost 40 degrees Celsius, the humidity, temperature. You see different plots that kind of represent live data. In fact, the time right now is 11:31 Eastern time, and that's, you can see live data coming in saying the humidity is 45.5%. Again, there are different ways there are different ways in which you can represent the data. There are other information, there are different types of plots, probably the direction of wind speed, the precipitation amount, so on and so forth. And finally, you can see where this data was collected from. It was collected somewhere, as we said, Uruguay, in a place called San Diego. So again, this is a representation of their IoT data. So now let's talk about how we can create our own channels and represent our data. So to do that, the very first step is we go to my channel and I'll create a new channel. Now in a new channel, you'll notice I can have a name. I've already used test 1 and test 2. Let's call this demo 1. And you can describe what this channel does. We can say, for example, it measures temperature. Then you'll see we have 8 different fields, and each field corresponds to data from a specific sensor. So if I have 8 different sensors, for example, field 1 could be something as simple as temperature. Field 2, I can enable it, and it could be something like pressure. So let's say, again, as an example, let's say you have an embedded device, a development board that you have in Quito, Ecuador, and you're sitting and you have a temperature and a pressure sensor on it. And the goal is to report that data into this channel. And that's kind of what we're trying to do, trying to set up to do here. While I can have many more fields, I'll just leave it to 2 fields for now. I can also, as you're going to see, I can have more information about the channel. For example, if your code that you're going to use is available in MATLAB and also is written in MATLAB but is available in GitHub, you can link to your GitHub repository. In addition to that, if there's a video that describes that kind of displays this channel information, you can also specify the path right here with the video URL. But with that said, the important steps here are to make sure you have a name, have the right fields, and then you can pretty much get started with your channel. And there we go. So you'll notice this creates a channel for me. My channel is represented by the channel ID. It's a unique number associated with my channel, the author who created the channel, and it says the access is private, which means you cannot, at this point, if you log into ThinSpeak and look at it, you will not be able to see it. But with that said, what is interesting is that it already has a few visualizations for me. It's empty right now because I have no data. But what is cool is that you will see it has already created some visualizations. I can add more visualizations. I have many options here, such as adding analysis, visualization. And again, we will look at all of this in our second part of the demo. But with that said, a few things I want to highlight here is you can, of course, make this channel public, as we are seeing, and that can be done in the sharing tab. And once you do that, you will see what others see for your channel as well. An important part I want to highlight here is the API keys tab. Now, your channels are associated with certain API keys. So if you want to write data into your channel, you would need to use this key to write. So this is a unique key. Again, I'm sharing it hoping that you don't copy my key, because each of you will have individual keys. And the idea is you would use that key to write data. Similarly, we have a read channel. If you want to read data from your channel, once it's already in, you would use this key to read the data. So remember that these are the important steps here to look at your API keys, the private view, as well as setting up your channel. Now, once you have done so, the next step we can do is we can try, as we said, we can try writing some data into the channel. So let's say the sensor you have that is set up in Keto is writing some data here. And what I'm going to do is I'm going to show you how we can write using the HTTP technique. And this is one of the ways. There are 4 different ways you can read and write data in ThinSpeak. And we're going to look at the first one, which is the HTTP way. And you notice there's a URL that already is here, and I'm just going to copy and paste the URL. And then you see my API key is here. This is my right API key. And then it's telling me for field 1, the value is 0. So let's say right now the temperature there is 40. So I'm going to enter a value of 40 for my first field for this channel. And as I enter the data, I get a response saying that it was accepted. And when I go back to my channel, let us see if I can see that data point here. There you go. You see a value of 40 was entered at 11:36 just now. That was my first data point for my temperature. So similarly, if your device now reports a different temperature of, let's say, 29, again, a few minutes later, let me again enter this value. And you see this is the second value that was entered, so it's accepted it. You'll see if I refresh my view for the channel, I'm going to see 2 data points where the first temperature reading was 40 and the second was 29. Again, I can of course do something similar for the second field as well. I can do field 1 and field 2. A lot of this information is available in the documentation that we will show you shortly. But this is at a high level. This is how you can write data to your channel. So, well, this is great. I have written some data into my channel. How can I read the data that I've written? So let's say your temperature has already measured, your sensor has measured 40 and 29 degrees already. Let's see how we can read this data. To read my data, I go back to API keys, and you notice read a channel feed. So I simply need to copy the URL that's there, and let me try pasting it here. You'll notice what I have here is my channel ID, as well as we expect, the read API key is also here. And when I enter it, this is going to give me in some form of a HTML header kind of format. It's going to tell me the values that were read. And no surprise, you're seeing the value that was read was 40 here for the field 1. And for field 1, the second instance, it read a value of 29. So if I know how to work around this data, this specific format, I can actually pull out that information that was read through the channels. So again, going back, just to confirm, the numbers were 40 and 29. We were not only able to read it in, we were also able to write data. So at the end of the day, so going back to our slides, so going back, I would just highlight one thing. So we saw how we first saw how we were able to log in to ThinSpeak. As I said, if you have a MathWorks account, just use it to sign in. If not, sign up. It's it's very easy and free to do so. And then you can create a new channel. Now in the channel, we saw a few settings like the ability to share the channel data, how there are different fields, and how each field represents a certain measurement or a certain sensor data. We saw a few public channels, or what they contain, how cool you can have cool visualizations and cool analyses. The final thing that I do want to show you here is also the benefit of ThinSpeak. Now, one of the big benefits of ThinSpeak is that it comes with MATLAB built in. So you don't need to worry about, I'm sure you're aware of MATLAB's capabilities as a computational engine. For example, in data science, in finance, for image processing, curve fitting, modeling, so on and so forth, you can use the same engine for your ThinSpeak analysis as well. So you'll notice under apps, there are several tools or widgets such as visualizations, where you can create good looking plots, analysis where you can perform analysis using MATLAB, and other apps such as ThinHTTP, time control, React, which let you, the third step of the IoT, if you remember, is acting on your data. And that's what these will let you do. For example, tweeting, scheduling your code, so on and so forth. Again, we're not looking at it just yet, but just know that this is available, and you will be looking at this with CJ in the second part of the presentation. So with that said, once we looked at that, once we looked at ThinSpeak, we then went ahead with the channel we created. We tried to send in a little bit of temperature data to see how you can write data into your channel. Once the data was written, we saw how it created some good looking plots with your data. And then we also saw how you can read this data back from your channel. And again, we followed a certain syntax. And the syntax was basically this URL with your channel ID and your read API key. Now, the idea is when you have your devices, your embedded devices, you want to make sure that they build this URL, and that way you can actually send in live data that is read in live in real time to ThinSpeak, and it'll be updated at every certain interval. Excuse me. With that said, I know we've spent about 30, 40 minutes talking about IoT and ThinSpeak. So let's quickly take a break. Let's take about 10 minutes break. The time now is 11:40 in my end. So let's probably come back at 11:50. So let's come back at 11:50. And in the meantime, for those of you who are new to ThinSpeak, please take a few minutes to log into ThinSpeak. Do create a channel and see if you can use these HTTP URLs to send some random simulated data to your channels. And if you've already done so, again, feel free to take a stretch break, and we'll be back in about 8 minutes from now at 11:50.
Trying to have a contest to make the most exciting channel too. If you make a channel public, feel free to paste the channel into the chat, and we can all take a look at your channel and see who can come up with the most exciting, at least channel name, because it's probably hard to get too much data in it right now. But feel free to share your channels in the chat. If you make a cool, exciting channel, not required, but we'd love to see your channels if you make them.
Again, in the meantime, if you have any questions, anything so far did not make sense, please let us know through the chat, and we'd be happy to answer your questions. If you're more comfortable, if you'd like to pose questions in Spanish, please do go ahead. Gabby can help us translate and address those questions too. So Alexander, I see a great question. Your question is, if I want to do a specific application, like a security system, can we configure something like an alert? Great question, Alexander. We definitely can. So an alert is a way of acting on your data. So absolutely, you can collect information, you can collect sensor data, you can perform analysis, and you can schedule alerts. And you'll actually see that in the second part of the demo that CJ is going to be doing. He's going to show you how you can have email alerts. Having said that, you can also have email alerts. You can tweet. So there are many ways you can actually configure and set up alerts. So great question. You absolutely can do it, and we will be showing you how you can do so with ThinSpeak and MATLAB in the second part of the session.
In case people stepped out to the break, we may want to re-answer the question again at 11:50, just to be clear.
Sure. I think that'll be a good way for you to segue into your parts of it too, CJ. Sure.
Sure. So Alexander, I see a great question. Your question is, if I want to do a specific application, like a security system, can we configure something like an alert? Great question, Alexander. We definitely can. So an alert is a way of acting on your data. So absolutely, you can collect information, you can collect sensor data, you can perform analysis, and you can schedule alerts.
And Alexander, just because I see you in the chat, I'll just also share with you a documentation link. So if you want to see how you can set up alerts, great way is to see act on data, and you can see how you can set up alerts. There's quite a lot of information here. I'm going to paste this link for you so that you can look at as well. But again, we will be looking at it through a demo, so don't worry. Xavier, so I see, thank you for sharing the link to your channel. I see you've made it public. I also see you have 3 fields with 3 different data points. This looks excellent. Thank you for sharing this. Very cool. I see temperature, humidity, and voltage. This is awesome. Thank you. And we see Christopher also has channel.
I accidentally only shared it with you.
Oh, no problem. We can put it on the group.
I added it now.
Okay, thank you. So this
This
is
is
Christopher's channel. Oh, with some fancy colors.
it's a Weierstrass function, which is a continuous function that's differentiable nowhere.
Oh,
Special math stuff. Weierstrass.
I don't think I've ever heard of that, but this is very cool. Thank you, CJ, for sharing this too. And Xavier, very cool. Thank you for creating and sharing your channel. With that,
Welcome.
CJ, would you like to start sharing your screen? Sharing your screen?
Sure. Oh, wait. Who did you say that to?
Oh, Xavier, no, I was saying thanks for sharing your channel. Great work. And
I think we're still about 2 minutes ahead of what you'd said. Did you say 11:50?
yes, yeah.
But I guess I could just to have it set up. Let me rearrange my desktop here. All right. Let's make sure we have everything up. Oh, slides. Channel concepts here. Compartir. Pantalla. Practicing. All right. Still another minute. Guess I should be in presentation mode. Do fast version. There we go. Can I maximize this? Anybody else got a channel to share? We'd love to see it. Controls go. What is it? Is Ecuador's southern hemisphere? So is it summer there? What's the weather like for you guys? I know there's a lot of people to ask, but anybody a weather expert?
Well, it's usually summer. Well, it's different because over here winter it just gets really rainy, but it really gets really rainy all around the year because global warming and all that stuff. So it's pretty much summer all the time.
Oh wow, Thanks, Xavier. So the temperature, I guess I could look online, but is it like over 30 C? I guess that's pretty hot.
Yeah, it's around 50. Wait, let me check.
Whoa.
Let me see. 63. Yeah, it's pretty hot.
Oh wow. That's Fahrenheit though, right? Hopefully.
Yes, it's Fahrenheit.
All right, 11:51. Thank you, Xavier, for giving me the weather report. I always like to know so I can feel warm, assuming I'm with my audience. But hopefully everyone is back. There's not a status. I remember I was in a training once where you had to manually set a little coffee icon to show that you were away, and then when you came back, you had to unchange it. We forgot to tell everyone to do that, but um, hopefully everyone's come back from the break and made some great channels. Still feel free to share those channels in the chat and tell us or share your exciting channels that you created, or have a look at the, I'll show you a lot more channels coming up or at the end of this. But I'm going to get going here, and I'm going to cover the slide that Ram stopped on. Just most of this is going to be a review, but this is sort of a collection of things we want to make sure you understand about ThinSpeak from the get-go, the start. As explained, a channel is a place to store and retrieve data that's organized into fields. So the channel generally represents a device, but it can also, like a single, an Arduino device. I've got a pile of them here on my desk. Here's a little ESP device. A single device posting data with up to 8 different pieces of data, but it can also represent a process. So you can have a channel that reads data from lots of other channels, and it can be your derived channel. So in general, it's either a channel is either a device or a process. The channel ID is the number of your channel. We're almost to 1.5 million channels now, I think. We crossed 1 million a couple months ago. We made a big post about it. It was exciting, but things keep accelerating. So unfortunately, that means you have to tell your best friend your channel ID. It's hard to tell them over the phone. You have to repeat it slowly, but the channel ID is unique to your channel. And there's only a few that I have memorized that are low numbers ones. One of my favorites is 1417, which is the channel for cheer lights, which I think I'll show you a little bit later, but it's a way to synchronize the color of your lights around the world. We have plenty of displays that are with cheer lights, but I can show you that later. The write API key, as Ram said, is basically a password that lets you write data to your channel. And the read API key is the password to read data from your channel. Those are channel specific. So even if you steal Ram's write API key that he showed you earlier, which he's probably going to change after this presentation, even if you stole it, you'd only be able to write to his channel, not to your channels. So, and especially if you made that channel private, you wouldn't even be able to see the data you were writing. But at any rate, those are your passwords for your channel. If you do share code, say like on a community site, we have a ThinSpeak community site, which I'll show you later. That I think it comes up later. If you do share code, try to write out your write and read API keys. People tend to share them a lot and not realizing that people could use it to write to their channels, which isn't a terrible problem, but a public channel is a channel that you've shared with everyone, and you don't need a read API key to read that data, and you don't even need a ThinSpeak license to see that channel. So anyone can go to that channel, as the example weather station that Ram showed you earlier, and the apps, which Ram gave you a quick show through, and I'm going to show you a little bit more detail, give you additional functionality. So the demo now I'm going to show you is a more advanced one, but to give you an idea of an application, we've made it into an air quality monitoring demonstration. The idea is to monitor air quality and send, and in fact, we'll end up showing you a way to show an email alert, which leads into the question. Unfortunately, I lost the chat window, but at the break we had a question about whether you can send alerts, and in fact, we're going to show you in this demo. I'm going to build up to that, show you a couple different steps, finally showing you how you can use the built-in email alert system to send an alert that of what the status of the carbon dioxide has been detected for the day. As Xavier mentioned, global warming, making it rain a lot more there, also making a lot more fires, and making carbon dioxide concentration an important thing to monitor. So this is becoming a more important thing, and I've created several monitors. I guess I have them here on my desk, but I was going to try to show them, but they're plugged in. Where is, well, here's an example one. This one's just wires, but you can see this is a BME 680 sensor, which you can use to build. Oh, here's the microprocessor board for it. And you can use this setup when plugged in. I was fixing it earlier today because I broke the antenna. But you can use this to collect temperature data. And I have several other ones here sitting on my desk, which are giving you live temperature data right now. As I said, wildfires, industrial design or monitoring of your own home. I've noticed myself when we cook, the carbon dioxide content goes up quite a bit when we turn the oven on, and also you can see it for heating in the day. So I'm going to show you, and also with COVID-19, obviously ventilation is an important thing in homes or in enclosed indoor spaces, so that can help you keep your air quality safe. So I think I will go away from this, and we will go into MATLAB, where I have a pre-prepared, and I'll also bring up this. Oh, that was my. I have a pre-prepared live script, which shows you all the steps of setting up your this demo if you wanted to be able to do it yourself. The electronics themselves, there's a Hackster demo that you can find to set up these electronics, and there's a lot of other demos on the ThinSpeak documentation that can help you set this up if you want to learn how to ingest the data from the device. What I'm going to show you here is more how to interact with the data once you've got it up. And you can do that with public channels. You can read other people's channels. You can read my channel. This here is a channel from a device I have sitting here on my desk, this little device with some pretty lights hooked up to it. This is the BME 680 sensor. They're sitting open. And this is a live channel showing me data from that sensor. Actually, I think I'll show you one more to show you the idea of a live sensor. This one, that BME 680 sensor is I can't remember the name of it, but this one here in this box is an NDIR sensor, so it uses infrared light to measure carbon monoxide. Wish the channel, I guess we'll have to refresh here. Sorry about this, I should have had it ready. And we're not going to be able to do this part. Oh, here it is. All right, we can see the carbon dioxide concentration here. And I'll briefly breathe into it. And maybe we'll see the value of the live data as it comes. Of course, it's going to keep refreshing. So as that's going in the background, we can see updates to the live data. It turns out my internet here at home isn't quite fast enough to share all of this at the same time. Oh, there we are. There's our CO2 data. So 1158. And we breathed into it, and we can see the last data point is starting to go up from my terrible breath and full of carbon dioxide. So now we can see the value of the live data from ThinSpeak, monitoring this monitor, sitting here measuring my hot air. All right, so now let's say we want to be able to do this ourselves. We've talked about creating the account and creating a channel. Hopefully some of you went through that. Please continue to share your exciting channels. Oh, we can see it really climbing here now in live. So we're going to skip those two parts, but we're going to, I think we'll be sharing this live script with you in the end so you can do it yourself. The next part I want to do is to get the most recent reading from a channel. So I'm going to do this here in MATLAB, but keep in mind that in the interface, the MATLAB interface in ThinSpeak, you can also do all this. And the third step, I will show you how to do that specifically, but we'll start here in MATLAB in case you wanted to do some advanced data in MATLAB. So here's two really short, easy lines of how you can get some data in. I've used the function ThinSpeak read. So I'm going to say the data that I want, my data, is ThinSpeak read with the channel ID, a field ID, and then here I've used what's called a live control in MATLAB where I can specify the field ID. If we wanted to understand what that ThinSpeak read function is, we can go to the help and we'll see it pop up here. The ThinSpeak read function to show you how it works. You can just specify a channel ID and that'll give you just the last value. For a private channel, you'll need to specify the read key to read data. And then there's several other parameters that you can specify. For example, you can tell it, I want an output format timetable for the data, and it gives you this nice timetable format with the timestamps as the data type. You can tell it, I want to read a certain number of minutes, and there's other, you can read a time range of data. There's other parameters that you can explore here that would give you pretty much everything you'd expect, you know, from the number of points to any other data format, hours, days that you want to be able to read. So back here to, we'll put this help function over here because we'll probably look at that again later. If I can resize it, I cannot. Yeah. So let's get the most reading. Control Enter. We'll run this section. So you have to find a section here in my MLX, and it's gone to the channel, and it's read the data. And then the second line, I just formatted it to a nice output. So it says text output here. The CO2 equivalent concentration is 517.51. And we'll go back to our channel here and scroll to the latest value here and hover over it. And if I click on it, should tell me. Oh, this is breath CO2. I'm sorry, I do want field 7. We can see the value, the last value here is 517 floating up there. Oh, there was my data. It hit the count. There's 515.28. Looks like I got one more data point. Let's see. Let's read again. See if it comes, if it'll update it to the latest 518 point. Can I run this? Give me 506.4. I want to prove this to you. This is right. 506.4. There you go. All right. Sorry about that. But this is the essence of real-time data. You have to update it right away. All right. Now I've got that data in a variable called my data. Now what I may want to write it back to a channel. In general, what I would probably do is do some more advanced analysis. But in this case, I'm just going to take that data and write it back to another channel. I think you'll see this is the channel I already shared with the Weierstrass function in it. But so here I'm going to use the function ThinSpeak write. We'll have a look at what that does. So the output of the function response tells me whether it worked or not. And I feed in, again, the channel ID, the data that I'm interested in inputting. In this case, I'm using my data, the value that I read from before. And of course, you'll need the write key to write to the channel. That's required, private or public. You can't write to a public channel if you don't have the permission to write to it, obviously. And of course, as before, there's lots of other options that you can write different fields. You can write string data if you format it in cell arrays, so on and so forth. For those of you familiar with MATLAB syntax, for those of you who aren't, read through the documentation carefully and you can see all the other exciting options. And in fact, it also provides you other testable code here. All right, so now let us write to the channel. Actually, first, let's look at the channel and prove, since things are so slow with my internet here. Can't even claim the children are actually in person at school, so I can't claim they're taking all the Wi-Fi. It's just me. I practiced this before I was connected. Can I shut down? Let's try shutting down Teams. Right, we are getting, here we go. This is going to show you a blank channel. This is going to be very exciting, I promise, to show you that there's no data. So I think we're going to go ahead and run it. I'll close the help. We'll run it and see, because the channel is taking some time to show up. Should have gone into work today. So, yeah, you can see it had 0 entries. And here's my field 1. And now we can see that data point 506.4 has been written Wednesday, January 19th. It's going to show it in UTC time here, but on the plot, 1900. GMT -5, right, because it's, okay, so I'm showing UTC time right now. At any rate, this data point was just written 1905. Why is today it was this my test data point? No, this is yesterday's data point, sorry. We have to prove it. Let's write my data. You got the right value. I'm sorry about this. Ah, there we go. Okay, we've written a second value. Why are my plots showing up? Is it, sorry, I'll have to check into this. I think it has to do with the slowness of the internet. It hasn't updated to my local time. At any rate, there we are. We can see I've written the data to ThinSpeak, written to the channel here, regardless of the timestamp. You can see that is how you would write data to the channel. Now, if we want to do something more exciting and get something more interesting, we can see a plot of what the cumulative values for the day in this monitor have looked like. So I'm going to read this channel now and summarize over hours. So again, I'm going to use ThinSpeak read. I'm going to put in the output form of that timetable I showed you. And then I'm going to use this function here called retime, which basically is just going to create hourly averages to make the plot look nicer. Just to show you the syntax for retime here, you bring in a timetable and then you tell it what you want to do. As you can see here, there's a lot of different ways you can retime. You can do it linearly. You can do it with a spline fit, a lot of different ways you can fit your data. I'm just doing a simple mean for that data. And then I'm going to use a bar chart. I'm not going to show you the help on bar chart because presumably you know what a bar chart looks like, and you'll see one shortly, and then change the Y label. So we're going to run this here in MATLAB, but then we're going to show you how you can do it also in ThinSpeak. And this will get us to where we can start to create alerts. Here we see a beautiful bar chart created in MATLAB, and we can see the peak of the data here is 2500. Occurs probably when the heat came on early in the morning. And this is my plot of CO2 equivalent. But I want to see this in ThinSpeak, and I want to be able to share it and see it update in real time. So let's copy the code. We'll go back to ThinSpeak here, and we will select on the menu, which is going to be quite slow. I have an idea. Channels. Oops, sorry. I do want to go to apps. See it happening painfully slow. And I will select MATLAB visualizations because I want to create a visualization. That's this bar chart here that I want to see, which I did have open already. So in order to speed up the internet, oh no, that's an existing internet. All right, here's my apps, MATLAB visualizations. I'm going to click new. You can feel free to even follow along if you wanted to, since the internet's so slow here. I'm going to create a new one. I've selected custom code. I meant to show you, sorry, there were a bunch of templates available there. If you're not happy doing MATLAB code, we provided you some code templates and you can select those. They provide standard operations like reading from a field, plotting a two-dimensional plot. But here I've copied that data, and now I'm going to paste it here into here. I'm going to name it. I'm going to show this as demo bar chart. And now this code is going to read from my channel, retime it into hourly data, and then plot a bar chart just like here. And this shows you the power of MATLAB built into ThinSpeak. I don't even need to open up a copy of MATLAB, which is a fun way to analyze data. But even if I don't, I now have this nice MATLAB plot on my channel. Even better, I can create a public URL to share that channel. If I sent this URL to my mother would be able to see this beautiful plot. And also, I can add that plot to a channel. So I've got a lot of channels here, but I could say I would like this plot to show up on, actually, let's see, the data store. Let's say I want it to be on, oh, I closed down that, sorry. I need to have a public visualization for it to show up on the public view. So I can tell it I want to show up on that channel that I've already shared with you, the one that has the cool plot on it. So now I save the display settings, and now this channel is live. This plot is live and available, and I can share it. I can go to my channel and see it anytime I want, and see a summary of the data for the day. I don't know if we will go back, refresh the channel so you can see that live, but maybe we will. Has it added it to the bottom? Yes, there it is on my channel. So now I've got a dashboard where I can see this in real time, which is a pretty exciting, useful plot. All right. let's continue now. That is how you can do it in MATLAB. If you want to do visualizations, you use the MATLAB Visualizations app. Now, let's think about something where we wanted to get an action from our channel without having to even be there. So I want an email alert, and this was to one of the questions that we had in the chat about how we can get notifications from our data. In this case, say I was the school principal and I had an air quality monitor in the classroom and I wanted to know if things had been safe for the students that day. So now I'm going to show you how to create an alert based on this channel. I've shown you, I have the code here, but again, I'm going to want to do it in ThinSpeak because I want to set it up to be automated without me having to intervene. I want it to send this email every day so I can know if it's been a safe day for the students or not. Fortunately, in MATLAB, I could do that and I could set a timer object, but I'd have to have an instance of MATLAB running on my computer every day, which can be kind of getting in the way since I may want to do some other great things in MATLAB. So let's see how we could set it up in MATLAB. I'm going to copy all of this stuff and then show you specifically what all of the code is doing. In fact, I think I will open up the visualizations app in the background, or the analysis app, sorry. Oh, it's going faster now. I'm going to start a new one. Again, we have templates here that can help you do things, removing outliers, read live data, this analyzes cheer lights for the most common color, that channel I told you about. But I'm going to use a blank one because I want to do fun stuff. And I'm going to go email alert. All right. And I will paste this code in here. Actually, let's make this a better one for CO2 demo because I want to be able to find this later. So now I've added my MATLAB code here, and let's go through and see what this code's going to do. It's going to read from that same channel we already created the bar chart from, and it's going to read 1 day of values. It'll retime it into hourly, and then say if the largest value is over some threshold. So let's make this exciting. We already see the plot, and we know the largest value is here at 2,500. So let's drop our threshold down to 2,000. We'll put ourselves in danger zone. I think for carbon dioxide concentration, we actually do want it to be under 3,000 is a dangerous level. So let's say we wanted to know at 2,000. So here's a threshold. Now we say we're going to do a comparison. If the largest value that we calculated in that hourly data is greater than the threshold, then make the message that we have to open more windows tomorrow, or if it's less, make it a safe day. One thing, actually, sorry, I did jump ahead here. I did want to point out, if you're not familiar with timetables, there's a handy way that you can refer to data within that timetable. So I've created my data with a timetable. Hourly data also is a timetable, but it's the retimed data. And now if I want to access a particular column in that, I can use dot notation. So hourly data dot CO2 equivalent will give me just the CO2 ones, and I can compare through that vector or array. All right, so now I've done the analysis and it's set this message called alert body. And now, if you've guessed ahead, the alert body I'm going to use in my email alert. So now I'm going to create the alert, and I can list a subject, and I've defined that subject into a variable called alert subject. I need to provide another special API key. You'll have to change it to your own API key, and of course I'll change this API key after. But you can find that in your account settings here under your avatar. You'll be able to find your alerts API key in order to set this up. Sorry, let's go back here so we can see. Oh, this window resize. There we go. All right. So now and then one other thing I want to show you that's exciting that you can do in ThinSpeak code is that you can embed functions in it to make the code cleaner to read. So the process of sending alert requires a couple of options. It's not terribly complicated, but it allows me to show you how that might work to have a function embedded. So I've made a function called create alert, which I've defined here as success equals create alert. You provide the API key, the body, and the subject, and it builds that alert. You have to use a web write and providing all the commands. I'm not going to step through this exactly, but keep in mind that just the idea is that you can use the function. There's also a nice template for creating an email alert if you can't follow along with this, or of course, you can see the template or look at the documentation for examples. In fact, I think I'll use this point to show you if you do get stuck and you want some help, we'll come right back to this, but say I was confused, under support here, I can go to the web documentation. I showed you how right-clicking in MATLAB, we can get to the documentation for the functions, which is great, but I may want more detailed help, and I've got some tutorials here in the documentation that show you more specific examples. So let's say, what is the one I want? Oh yeah. So here under the ACT section, there's a nice demonstration called Analyze Channel Data to Send Email Notification, which takes you step by step through the process of sending an email with code and explanations. So if you got stuck, you could go there. So now let's go back to the code. We are ready to send it. Hopefully everyone is now following along with this bunch of code here, which I tried to comment well. I hit save and run, and now it's going to do this process in the background, and it's going to send me an email. Often people ask me, can I send emails to multiple users? And the answer is no. You can only send emails to yourself, to the account that you've logged in with, because we don't want you to set up a spam factory here using our alert system. So now I've sent that, and I will, in the background, check my email and see. Oh, look at that. I got an alert. You guys can't see it because it came up on the other screen, but I wish that I could have set that in advance. So now we'll go to my email. I'm opening this another screen and see that I've got this air quality alert summary for today. And it says open more windows tomorrow as expected. Since we dropped that threshold down to 2000, it said we were dangerous. And now I want to run this code so it happens every day. I don't want to go in here manually and do it. So how would I do that? There is an app for that, fortunately. So I'm going to go into the apps. And there's two ways that you can do that. There's one app called React and one app called Time Control. We're going to start with Time Control, which is actually the more complicated method that I can do that. But I'm going to show you that can let me schedule this code to run on a daily basis. So I should have logged in with my spare account because I have too many time controls running here. I cannot create a new one because I've already got the maximum set because I set a lot of demos. So let's assume that I would have clicked new, and I will show you the edit options for a time control. So here's a time control. This is where I would be. Actually, let's maximize this so you can see it. If I had created a new time control, and I would say demo air queue control. And I want it to be recurring because I want it to happen every day. And apparently here you can see this one I had set up at 8:43 p.m., which seems like a good time to get an air quality control. I can change this to weekly. I can change it as often as every 5 minutes that I can schedule this code to run. I can also use fuzzy time. That'll add a random change to it in case I was doing some sort of process control. And here I can select the action. You remember we set up a MATLAB analysis, and then I can select the code to execute. So now it was the last one we made. I would go all the way down to email alert for CO2 demo, and then save the time control, and this would run every day. Now, of course, this is one I already had set up, so I'm not going to save it and change it, but in fact, I already have some set up to tell me the air quality every day. But this time control is how you can set up ThinSpeak to run on an automated fashion. There is also, Ram, feel free to stop me if I'm not monitoring the chat, so if there is anything that comes up, you can interject at any time, or feel free to add your any questions if I'm going blazingly fast or you wanted to some refinement. I'm also going to show you a secondary way that you can set that up, which is the React app. You saw, presumably, in that code that I wrote, and actually I think I will bring it back up. We'll show the MATLAB version of the code, that I did some processing in my code, I did this, is the value higher than something, because I wanted to use some refined data. I did that retime thing. If you just want to use the data from your channel, you can use the React app. Let's see if I can build a new React to react to conditions in a channel anytime that the channel reaches a certain value. So for example, here I could have a React and I can say I want to use a numeric React and say I want to check the channel, say every hour. I want to know if my channel, which is, I've got some air control ones, but since I have too many channels, I can't find it here. So let's just say I'll pick this air quality channel, which is a different one that's in the parking garage at MathWorks. And I say if this field is greater than a certain value, or I can set other conditions. I can say, say the dust concentration field 5 is less than a certain value. And I say what action. I can again run that MATLAB analysis. In this case, I probably wouldn't want to do the comparison in the code, but I could select that code, or I could select any other code that I've written to do some action if I detected the dust concentration is higher. So this one builds in some conditionals so you don't have to do it in your code. That's how the React app works, and then I can save it. One kind of exciting thing is that you can do it on data insertion, and this will actually let you get around the 5-minute limitation of the time control. You can only have one of these on data insertion Reacts per user, but this is a way that you can have, say you wanted to process data as it comes into your channel and you wanted to analyze every single, or clean every single piece of data. You can do that, and then of course save React, and it will begin to run on the condition that you showed. All right, so that is the React app, and that shows you how you can set up your code to run in 2 different ways, using time control and using the React app to run code on a regular basis. So here we are back. Yeah, I think that's the end of the MATLAB script. I think we'll be sharing this script with you if you want to try it, or as I showed you before, you can get that in the data yourself. And I do. I want to note this data was demoed on a plant that I had in my office, and it had measured the plant soil humidity, the soil moisture content, and it did a great job of keeping the plant alive for about 4 years of this demo, but recently, about a month ago, the plant decided it didn't want to be around anymore. So we're in flux with growing a new plant, which we can monitor with ThinSpeak. I think there may be even no, and in one of these demonstration channels, there is a picture of the plant if you wanted to see what he looked like before he died. But right, so
EJ,
that's the. Yeah, please go ahead.
Looks like there's an interesting question from Alexander about combining results with other simulations in MATLAB in the chat. Would you like to?
Can I get? Oh, here's the chat. I can see it. All right, let's expand. So yes, this is. Can we combine the results with other simulations in MATLAB? For example, combine data about sensors with a physical laser simulation. What about the processing load? So that's a great question. Definitely, you can do. You can put ThinSpeak read statements in your other MATLAB code. So if you had a MATLAB script that's running some other analysis, you can put the ThinSpeak read into it. I think generally the actual, yeah, you saw some delay that was slow because of mine, but we can find out. That's a great question. I'm gonna do a ThinSpeak read. You can time it here. We'll just add a tick and a talk just to answer his question directly. It should be on the order of hundreds of milliseconds or less. I'm not sure. It might be longer. Let's run that selection. F9. So we got 347 milliseconds was how long it took to read data from ThinSpeak. So it's not going to be as fast as every other, as a write to memory, but you can put this into your code, and it will still it will still do fine in process. You also asked about simulations. I'm not sure if you were referring to Simulink simulations as well. Simulink, of course, is a graphical simulation environment that runs in MATLAB. And Simulink actually has blocks for ThinSpeak read and ThinSpeak write. So you can make your simulation with your Simulink blocks and then have it retrieve and or write data into ThinSpeak during a simulation. So yes, you can definitely combine simulations. And the exciting thing, as Ram mentioned, if you had a sensor located locally or remotely, you can read data from that sensor no matter where you are. So I can, I could read a sensor from your location and have it running in my code locally. So that's the power of the cloud. So yes, definitely ThinSpeak, you can combine simulations, you can read it in real time, or you can read and download the data in real time. And download the data locally to MATLAB and do your analysis there. One thing I do want to point out, this is if you have a large amount of data you want to read, the ThinSpeak read function is limited to 8,000 data points. So if you wanted to read 8,001 data points in your simulation, you wouldn't be able to do that. You could do it with multiple calls. You have to be careful writing programmatic calls to ThinSpeak because we don't want to slam the server, right? If you wrote a programmatic call that could read it 1,000 times per second, that might get you blocked from the server. So you have to be careful with that. But if you do want to read more than 8,000 data points, if you have an application for it, we have a beta service that does historical data. You can reach out to me directly if you had that application. But in a future version of MATLAB, that capability will also be available to read more than 8,000 data points with a single call in MATLAB. For now, if you wanted to do it, reach out to me or use multiple calls. Right. So hopefully that answers the question about Simulink and simulations. And definitely, please involve your ThinSpeak read in your data. And if you come up with cool ways to do it, share it with me, please. We always want to hear about the fun things that people are doing in ThinSpeak. All right, I think there might be a few more slides now, unless there are other questions. I guess I'll pause and see if anybody had any more questions about. Okay, thanks. Good. I'm glad that I hopefully didn't confuse it too much by bringing Simulink into it. Sometimes people think that's Simulink is a fun tool, but that it gives you a lot more power too, which can be confusing. So no more chat questions in, so I think I will continue here on the presentation. Can I get, right, don't do that, please. Don't go out of this. Control 5, Shift, yeah, there we go. All right. So in summary, we're gonna start winding down here. I'm gonna show you some other cool stuff still, so it's not quite the end. But ThinSpeak allows you to access data. There, as Ram said, there's 4 ways to read and write data from ThinSpeak. You can use the REST API, that's the HTTP interface. There's another interface called an MQTT API. And you can use ThinSpeak read and write in MATLAB. And you can also use Simulink to read and write data from ThinSpeak. You can use devices to write to ThinSpeak. You can also write and read from MATLAB, of course, and Simulink. But for your devices, if you use Arduino devices or ESP32, ESP82, 66, other Arduino compatible devices, we provide a library for both Arduino and Particle devices that can help you interface with ThinSpeak from your devices. So just search on GitHub or in File Exchange. And we offer support packages and to let you read through Raspberry Pi. And we also have a way to read LoRa data through the Things network. So lots of different ways to access data. There's also even some other interfaces for industrial IoT platforms that are available. And you can read more about those on the webpage where Ram showed you initially with the different blocks for the different applications. So you can visualize and analyze the data once you get it into ThinSpeak. You can do analytics, complicated charts. Ram showed you some widgets you can put in for fast readout on your channels. You can also build custom apps in MATLAB. There's MATLAB provides an application called App Designer. This is just a screenshot of an app I wrote in MATLAB, which allows you to compare data from, say, this week to last week. and it has some live controls where I can press buttons and see data in real time. In fact, since we're only at 12:30, I'll show it really quick because I already have it open, but here's the Data Explorer. I'm not going to go into this too detailed since many of you said you had not had a lot of ThinSpeak experience, but as the pandemic hit, I wanted to understand, comparing current data to previous data from the, this is a car counter channel showing the density of cars on a traffic, on a street outside of the MathWorks headquarters. Here I've read some data from the 11th of January and compared to the day before. So this is a Monday compared to a Sunday, and you can see here the effect of people getting up for work. And the blue data is more intense for the number of cars compared to people sleeping in. There's much less red data for the holiday day, or sorry, for the Sunday data here. And I can see here I'm comparing data from one day to the day before, but here I've set up the controls so I could say, let's compare data from a week before. So sorry I jumped into this. I had it open. I wanted to show you. You can build these kinds of apps which read ThinSpeak and give you live data controls. And you can also do predictive modeling. This is an example of a time series example where I do predictive modeling, showing where I expect a signal might go. And then finally, the last step is to act. So you can use the apps, time control and react to set up actions that will happen based on your data. One of those actions might be alerts. And another action might be to integrate with other services. You can integrate with Google or download your data to an Excel spreadsheet or interact with IFT to set up control for a mechanical device. Or you can set up your mechanical device to read directly from your ThinSpeak channel and take an action that way. All right. Finally, key takeaways. ThinSpeak allows you to collect, analyze, and act on your IoT data. You don't have to set up a web server yourself. You don't have to have expertise in web technologies. ThinSpeak runs MATLAB for advanced analysis, as we showed you. Oh, and yes, and that's what gives it tremendous power. You can get your data in and out easily, and then you can run MATLAB on it to analyze the data. To get you excited about lots of projects, I wanted to show you some public channels. This is a gigantic array of them, so I'm going to step through them pretty fast. But I'm just going to mention some, and these are public channels that you can read yourself and use the data there to do exciting things. We have a weather station in the MathWorks headquarters in the parking garage, which collects lots of different data, wind speed and temperature. We have a traffic monitor, which I mentioned, which uses a web camera to do blob analysis. Here's a solar water heater from a math worker in the UK, again showing the worldwide nature of where you can read data from. There's an outdoor air quality monitor, again in the parking garage at MathWorks headquarters. An indoor air quality monitor. These are ones in my house. I've got a channel here which tracks some COVID data, and this shows you how a channel might be used for a process instead of for data from a device. This uses a web scraping process to collect data from an external site and just show it on the channel. The Cheer Lights channel is just a color where you can use your devices and read it and have your devices display that color. Especially around the holidays, it's a nice way you can synchronize around the world. And then if you send a tweet to @cheerlights with a color, you can change the color of people's displays worldwide, since they're all reading cheerlights, including a couple of them that I have outside for my holiday lights celebration or decorations. Here's the soil monitor. Oh, here's that picture of that plant that I mentioned. Unfortunately, this plant is no more, but this channel shows you the soil moisture. And right now, if you read it, the soil moisture is very, very low since I haven't watered it for a while since the plant is no longer living. But I have some seeds and I plan to plant it again. All right. And here's some further learning resources. Ram and I recently completed a video series which shows you the step-by-step way to go through all of these ThinSpeak steps. There's a MATLAB on-ramp which you can use to learn MATLAB. And we have the documentation examples, which I showed you, and also the IoT solutions pages where you can get some ideas of maybe even doing commercial applications with ThinSpeak. Here's a nice way showing the blobs detecting of cars going by on the highway. So I think at this point, I could either turn it over to Gabby or Gabby, would you be able to take us through to the end?
Sure thing. So let me just share my screen real quick. Let's see. Make sure that I shared the right one.
I have to stop sharing.
I think I just took the power from you. So can you confirm if you can see my screen? Yes. Okay. Thank you. So I'm going to switch into Spanish. Como ustedes ya a lo mejor saben, ustedes tienen acceso, la EPN tiene acceso a una licencia de campus que les da acceso a, bueno, básicamente todos nuestros productos y no solamente a productos, sino también a cursos interactivos o tutoriales interactivos. Ustedes pueden acceder a la información de la licencia aquí en este enlace. Déjenme entrar rapidito. Ahí ya que me abrí fue en la otra ventana. Y como ven, pueden acceder directamente a iniciar sesión o a crear su cuenta, que bueno, ya me imagino que ya la habrán creado hoy en esta presentación. Pero ven también que tienen acceso gratuito a los cursos en línea y otros tutoriales. Y les voy a mostrar aquí rapidito cuáles son estos cursos que pueden encontrar en esta página que se llama MATLAB Academy. Entonces, si nos vamos a MATLAB Academy, vemos que están divididos en diferentes secciones, tanto, bueno, cursos introductorios, entonces para aquellos que son completamente nuevos en MATLAB, pueden tomar el MATLAB OnRamp, que básicamente los guía, bueno, a través de las nociones básicas de MATLAB, y vemos también que está dividido en secciones, así que si ustedes ya tienen alguna experiencia de MATLAB, pero a lo mejor quieren enfocarse, no sé, en vectores y matrices, pueden tomar ese módulo en particular. Y al final, lo que pueden hacer es generar un certificado. Y ese certificado puede ser en formato PDF o puede ser, bueno, en un enlace que pueden compartir en su currículo, en sus redes sociales o con sus profesores para mostrarles que efectivamente terminaron el curso. Y bueno, no solamente son estos cursos introductorios relacionados con las herramientas, sino que también hay en la parte, bueno, de simulación de circuitos, áreas en inteligencia artificial como Machine Learning, Deep Learning. Así que hay muchísimos cursos y cada vez estamos agregando nuevos, nuevo de comunicaciones inalámbricas. Así que bueno, les invito a sacarle provecho a esa información que tienen en esa información, a esos recursos que tienen a través de su licencia. Y cualquier cosa, si tienen alguna duda, yo soy la ingeniera que está a cargo bueno, de la relación de MathWorks con Ecuador y con otros países de Latinoamérica. Y Enet Corral, que no nos pudo acompañar hoy, es la persona encargada de la relación comercial, ¿sí? A asegurarse que tengan acceso a la licencia y todo eso. Y igualmente nos pueden seguir en nuestras redes sociales. Yo estoy súper activa en LinkedIn, así que si tienen LinkedIn, ahí comparto bastante información acerca de eventos y de recursos. Y también si usan redes sociales y quieren utilizar el hashtag Yo hablo MATLAB, también pueden contarnos acerca de su experiencia utilizando ese hashtag. Ya vi que había algo en el chat. Dame un segundito. A ver. Oh, sí, el link que Christopher envió. No sé si hay alguna otra pregunta o si los muchachos que organizaron quieren hacer otros comentarios o el profesor Roberto. Dan.
Claro que sí. Primero que nada, agradecerles a los expositores. Fue súper interesante la charla. Me parece que hay muchos temas de interés, en especial para nosotros los estudiantes, ya que podemos enfocar este tipo de conferencias a futuros trabajos de investigación, por ejemplo, para futuras tesis. Me parece que es súper completa esta herramienta que han mostrado el día de hoy. Eh, una pregunta un poquito fuera de lo que se expuso sería si podríamos seguir organizando este tipo de eventos y después al final ya haría una invitación un poquito más oficial.
Sí, claro que sí. Bueno, eso precisamente es parte de mi trabajo, organizar o presentar ese tipo de eventos. Así que con gusto podemos seguir en contacto y enviarles las informaciones de los eventos que realizamos también, que son públicos y gratuitos para cualquiera.
Perfecto. En ese caso, también me voy a permitir hablar un momento. En la Escuela Politécnica Nacional estamos organizando una nueva comunidad de desarrollo IoT llamada IEEE IoT Community, en donde el registro y la suscripción es totalmente gratuita, tanto para miembros y no miembros IEEE. Así que les animo a unirse a esta nueva comunidad. Va a ser una comunidad de desarrolladores para todo el país, primero. Y segundo, quisiéramos enfocarnos en este tipo de talleres para después sacar proyectos de investigación como tal. Entonces, no sé si es que también podríamos contar con ustedes, con la gente de MathWorks, para seguir trabajando conjunto y hacer algo súper bueno al final.
Sí, con mucho gusto. Bueno, ya tienen mi información de contacto, así que cualquier cosa nos podemos seguir comunicando por correo.
Perfecto, muchísimas gracias. Aparte de eso, no sé si es que al correo me puede mandar un poquito más de información sobre los expositores para poder generar los certificados de participación en el evento de IEEE.
Sí, con mucho gusto. Y lo otro que le vamos a compartir también son las diapositivas y sí, el material que se utilizó hoy para que tengan, bueno, una copia del material. Entonces, eso también se lo hago llegar por correo en esa comunicación.
Perfecto, muchas gracias. Es eso nomás. No sé si es que existe alguna otra pregunta por parte de los asistentes.
A ver, ¿hay nada en el chat?
Bueno, me parece que no hay ninguna otra pregunta. Me parece que podemos dar por terminada esta sesión. De nuevo agradecerles. Estuvo súper interesante. Me pareció que podemos sacar de este taller, podemos sacar muchos talleres más. Me pareció muy interesante, en especial la parte que se nos mostró al final sobre control predictivo, me parece que era. eh, bueno, podríamos seguir hablando para talleres a futuro muy interesantes. Muchas gracias de nuevo y gracias a todos los asistentes por acompañarnos el día de hoy.
Muchísimas gracias y muchas gracias por la invitación. And thank you, Christopher and Ram, for your presentation. They were just saying that they're super excited about this event and that they want to continue since they have a new community, like IEEE IoT community that they're starting. So these type of things would be super helpful for them.
Fantastic.
Absolutely. Yeah, happy to help in any way. And yeah, we look forward to working with all of you as well as with Professor Roberto. Thank you.
Gracias por su atención y
Gaby,
por usar ThinSpeak.
That was perfect. Yes.
I was nervous. Thanks,
muchísimas
everyone.
gracias, Gaby. Thank you, Christopher. Thank you, Ram. Thank you so much.
Of course. Thank you.
It's a pleasure. Thank you.
I haven't seen the icons in WebEx. This is exciting. For
Yeah.
different claps. I want more fireworks. Is there any fireworks?
I can do thingy.
Oh, that's like fireworks. Thank you. Oh, Eric got it too. Fantastic. Yeah. If you have questions, feel free to try the forum that I put the link for. I monitor it all the time. So
Yeah, totally.
fantastic. All right. Does it give us an attendance report, Gabby?
No, I don't think so. I can check with the organizers later
Sure.
if they can share that.
And Gabby, I will share with you the PDF and you can share it with everybody or the professor
Oh,
for the presentation as well as the slides
Awesome.
and
Thank
the
you.
MLX.
and the
Yeah.
MLX file. Yes.
It's in the shared. I made a shared folder within your SharePoint thing. Share. That's too many shares.
Yeah. I will add all of it there so Gabby has it.
Thanks.
Perfect. Thank you. Thank you so much. This was, I learned a lot. I hadn't
Oh,
worked on that last part of the ACT part. So, yeah, the notifications, that was
Gabby,
super interesting.
Gabby, I think you can launch the report. I talked with Elvis to ask if he can help me with the report. I see we have 40 attendants.
Yeah, that was really good. Thank you so
Sí,
much for organizing this.
it's very, very good.
Sí, yo también puedo
Because
compartirle la lista de quienes asistieron porque me aparece a mí en el reporte de Webex, ya que la cuenta como es nuestra, nos aparece quién entró.
Buenísimo. Yeah.
para que nos ayudes. Sí, it's very good the number because students are in this week is evaluation or have a lot of evaluations. So that is a good number.
and we didn't seem to scare them all away. They stayed on mostly till the end. So
Yeah, it was good.
Students attending to the conference have 1 point more.
Oh,
It's important
nice.
that
They had extra points.
it's
Nice, that's good. Okay, so I think I'm gonna jump off. I have a
yeah, you said you
presentation
had to
after
go.
this.
Good luck, Gabby.
Yeah,
Good
thank
luck.
you.
Yeah. Good luck, Gabby. And thank you, everyone, once again. Have a good day.
Thank you.
Thank you,
Have a good
everyone.
Go too.
Good luck.
feliz día.
Thank you. Bye-bye.
Gracias.
Everyone, thank you.
Thank you very much. Have a nice day.
Thank you.
nice days. Thank you so